Good evening, students. Happy New Year to all. Yes, last class we studied that in 9th standard science. The topic is motion. In that lesson, we learned what is motion, what is rest and motion, types of motion. What are the types? That is uniform and non-uniform motion, and their example also, and that concept of distance and displacement. What is distance and what is displacement, and that some more topics, speed, velocity, and acceleration. Okay, in this session, now I'm going to teach the explanation about that graphical representation of a motion. First one is distance time graph for that uniform motion. In uniform motion, how the distance time graph will be get. Okay. For example, I'm going to usually all our we want to maintain our body in good condition, means definitely the walking is a very good exercise, very good manner. Okay, so in that manner, most of the peoples are usually they want to maintain our health in good condition in all time in our life period. So we follow the walking and exercise yoga like that. So walking is a very good exercise for body maintenance. In this distance, why I'm told this walking, this graph, one person is walking in early morning in that open space, because there is no traffic in that place. Early morning means our mind also very fresh in that time also. So that time that work was done in a good manner also first. So that motion also in that uniform condition. So why I'm told like that, in this graph we need time detail and then distance details. Okay, so that person usually he walking on that plain road or in very good park or that open area. So the time is he maintained the time in proper manner. Okay, so for example 0, 5 and 10, 15 and 20. So the time schedule is increasing in fifth table. Okay, 5, 10, 15, 20, 25 like that. Yes, he crossed the distance also. Distance is mentioned in meter and time is mentioned in minute. Okay, so time is mentioned in minute and then distance is mentioned in meter. Yes, in 0 minute he crossed 0 meter. In 5th minute he crossed 500 meter. 10th minute he crossed 1000 meter. 15th minute he crossed 1500, and then 20th minute he crossed 2000 meter, and 25th and 2500 meters. It is that increasing order only. There is no variation. The uniform motion. What is the meaning of uniform motion? Yes, uniform motion means we want to maintain the distance as well as the time. Both are in the same same manner. There is no difference in this area. So 0th minute, 5th minute, 10th minute, 15th minute, minute, and when 25th minute, so 5th minute he crossed 500 meter, 10th minute 1000 meter. So this is the very good example graph for uniform motion. Okay, in uniform motion means that time as well as the distance both are maintained in same condition only. This is fifth table, 5, 10. Same condition, 500 and then 1000, 1500. 500 meter only he cross each and every 5 minutes. That is the gradual, stable motion. Okay, yeah. So the motion time is increasing each and every part. That is 5 minutes only increased. Same manner, each 5 minutes he cross 500 meter. So this is the gradual speed, that is uniform motion. When we want to draw one graph for this data means x-axis and y-axis. Okay, so this is x-axis, this is y-axis. We want to maintain that x-axis and time, that is minute. Y-axis is distance, that is meter. So we want to write the time data in x-axis. We want to write the distance data in y-axis. Yes, time means this is 0, 5, 10, 15, 20, and 25. Okay, these are all the minutes. Same manner, 500, 1000 and 1500, 2000, 2500. So this is the distance data. Yes, 0. First 5th minute he crossed 500 meter, and then 10th minute he crossed 1000 meter, 15th minute 1500, 20th minute 2000 meter, 25th minute he crossed 2500 meter. Okay, so now I want to join the points. Yes, we got a straight line. Okay, so we got a straight line only. So this is the very good example details for the uniform motion. Yes, what is uniform motion? Uniform motion concept, the person covers equal distances in equal intervals. Yes, each and every interval he cross 500 meters only. So the conclusion, this is uniform motion distance time graph. Okay, how we can calculate the speed? Yes, the formula of speed is, yes, already we studied that. Distance covered by time taken. Yes, this is the time taken. Details, this is the distance covered. Okay, so distance covered by time taken. How many distance he covered? He crossed, yes, 500 meter. Time taken period is 5 minutes. So 500 divided 5 means 100 meters. Okay, 100 meters per minute. Each and every minute he cross 500 minutes means per minute he cross 100 meter. So this is the right speed. Okay. So 100 meter per minute. This is the answer. 100 meter per minute. Per minute he cross 100 meter area. So that speed and then time taken and then distance are equal. So this is the right example for the uniform motion. Okay. So is that clear, ma? Uniform means the distance time graph express the person covers equal distances and equal intervals of time. So that speed is constant. That is per minute he cross 100 meter. So the uniform motion concept is explained with the help of this graphical data. Is it clear, students? Okay. Next one is, next graphic means that is comparison of speed. In this graph, a single person is walking in this area. But we want to, in morning time, we want to do our work. Each and every persons are doing their work depends upon their facilities. Yes, students are using usually public bus, and then office goers are usually use their own vehicles like cycle, and then two-wheeler, four-wheeler, like that. So depends upon their facilities. We are using that vehicles, or by walk also. Some students or some peoples usually they are using their own vehicle, that is walking. That is a very good exercise also. So they different kinds of persons. Some persons are riding in a car, some persons are cycling, some persons are walking, and some persons are using two-wheeler. So different kinds of vehicles. In that manner, we want to draw a graphical structure for that area. Means how can we maintain the speed, how that graphical structure will come. This graph is express the comparison of speed. Comparison of speed, how the speed is varied. How the speed is vary for each and every persons. Usually this is x-axis, this is y-axis, this is time, heart, y-axis we want to maintain distance, kilometer. So time is usually we can calculate that hour, manner, and distance in kilometer. So distance time graph, then comparison speed. Okay. So first one 0, hour means, so 1, 2, 3, and 4. Because this is hour, first hour, second hour, third hour, and then fourth hour. So you want to maintain the distance in kilometer, 20, 40, 60, like that. Okay. So first person, what we want to draw this graph means first person is cross the distance by walking. So walking is the slowest part. So walking means, yes, nearly 25 minutes or 20 minutes he cross 3. Within 3 hours he cross 20 minutes, 20 kilometers, sorry. And next person, he crossed the distance by cycling. Yes, he crossed 300 hours. Timing period nearly 50 kilometers. Next person used, yes, car. So compared to walking, cycling, third person was cross that area, his car. So the speed of the car is higher than the cycling and walking. So comparison grade, walking means that person cross only 20 to 25 kilometers in 3 hours, and then second person cross within 4 hours. That 4 hours means that same nearly 50 kilometers. So 300 hours period, he crossed more than 60 kilometer. This is the highest speed. So in this manner, we can identify, we can learn the comparison of speed. Comparison of the speed and time, distance time graph means 3% would given that different kinds of speed. So the slope also in difference. It is a straight line, but that graphical structure is differ, not in gradual. It is not uniform motion. It is the example of comparison speed. Okay. Next one is distance time graph in non-uniform motion. Non-uniform motion means distance and then time interval is not equal. Distance and then time interval is not equal in non-uniform motion. So non-uniform motion means the distance I grab the accelerated motion. So by a car, okay. So in this graph, we are taking the vehicle or car. So how the graphical structure? Yes, we want to first write the datas, time and distance. We need these two datas. Time in a second because this is car. Distance in meter. So each and every second how the car is crossed that area. Okay, 0 second, 2 second, 4 second, 6 second, 8 second, like that. 0 second, cross 0 meter. 2 second, he cross 1 meter. 4 second, 5 meter. And then 6th second, 8 meters. And then 8th second, 10 kilometers, 10 meters or 12, like that. So, just you look at the data, the time duration and the distance process is not an equal. So this is the example of non-uniform motion. Non-uniform motion means that just we can clearly, yes, we identify the details in uniform motion. That person was cross equal distance in equal intervals of timing, but here that person is not maintain the equal distance in equal time duration. Okay. I'm going to draw a structure, graphical structure. This is x-axis, this is y-axis, time in second, distance, meter. 0 second and then 2, 4, 6, 8 and 10 meter, 5, 10, 15, 20, 25 like that. Okay. First 2 second. 2 second he cross only 1 meter. First 0 second means this is in 0 point. First 2 second he cross only 1 meter. 4 second he cross 5 meter. And then 6 means he cross 8 or 9. Okay. And then 8th minute he cross 14 meter. And then 10th means 22 like that. Okay. So I want to join the dots. Yes, this is not straight line. This is a slope. Sit or not? Yes, this is the slope. In the slope, we can identify the non-uniform motion of speed. So this nature of the graph shown the non-linear variation of distance traveled by the car with time. So the graphical structure represent the motion with non-uniform speed because the car is crossed. First 2 second he crossed only 1 meter. Second 4th minutes means 4 kilometer. So 2 to 4. Yes, these two difference. He crossed 4 meters and 6th second he crossed nearly 10, that is a 9th meter, and next one is 8th second he crossed nearly 15 meter. 10 minutes he crossed more than 20. So the speed of the vehicle is not equal. So this is the difference between uniform and non-uniform. Uniform means the person cross the distance and the travel of the times are both are equal. They maintain proper timing as well as that distance also. But here this person cross the area in different kinds of speed. So this graph is express the non-uniform motion of speed. Okay. So is that clear, students? Yes, we can understand the uniform speed as well as the non-uniform. That is distance time graph of uniform motion as well as the non-uniform motion. Okay. Next topic is velocity time graph. Next we are going to learn the velocity and time. Velocity and then time. How the velocity and time is want to maintain. In this graph, in that time is represented in x-axis usually, and next one is that velocity. Velocity is expressed, represented in that y-axis. Velocity is represented in a y-axis. So in velocity time graph means the graph shows the speed of velocity time graph of a car moving within the uniform velocity, that is 40 kilometer per hour. Yes, uniform speed means uniform motion. The distance and the time travels are equal. So this velocity time graph also, that velocity of that car is 40 kilometer per hour. Okay. So the 40 kilometer means each and every hour the car crossed 40 kilometer. So the velocity time graph is equal to the magnitude of the displacement. So the distance covered by the car in that proper time travel. Okay. So proper time travel means the graphical structure. Also, we will get the proper structures. 0 hour means 1, 2, 3, and 4 hours. Next axis. In y axis, want to write the velocity. Velocity is kilometer, that is 40 kilometer per hour. Okay, so this is time in hour. In first hour, he crossed 40 kilometers. And then second hour, that same 40 kilometers. And third hour, he crossed that same 40 kilometers. That is 10, 20, 30, 40. 40 means each and every hour he crossed the same 40 kilometers only. He crossed the 40 kilometers only. That is the velocity. So, yes, we will get that. Graph means we want to join that graphicals. Data, that is, you want to denote the this is A point and B and C and D. Okay, so the area, yes, this is look like a rectangle. Okay, so we know the formula of rectangle. Yes, speed is area of the rectangle ABCD. This is the speed of the car. So here we want to calculate the speed means, how can we calculate the speed means A, B, C, D. These are all the points. So we want to write, sorry, this is C and this is D point. So A, C and multiplied to CD. The speed of the car we want to calculate means AC into CD. We want to multiply the AC details and into CD datas. Okay. So that uniform acceleration motion by the its velocity time graph. So the car is being driven along a straight road. So each and every 5 seconds, the speed of the car is maintained in normal same speed. That is uniform speed only. So the velocity for every 5 seconds noted the speedometer. So the velocity of the car in meter second per -1. So different in that time shown. So each and every 5 minutes he cross 9 kilometers. The uniform accelerated motion means velocity time graph. Here, so time and then velocity. So each and every 5 minutes, that is 0, 5, 10, 15, and then 20 seconds, he crossed 9 kilometers, 18 kilometers, and 21. This is a ninth table. Is it? This is fifth table. So the time is gradually increased 5 seconds only. So the velocity of the speed also increase in 9 kilometers. So the velocity of the car, that is cross 9 meter per second. Okay. So this is the right structure, data of uniform accelerated motion speed. Okay. So velocity time graph, yes, express the normal gradual increasing of velocity of the vehicle with Yes, that in uniform acceleration motion. Non-uniform acceleration means, yes, the graphical structure is differ from that. Okay. Now, I am going to explain the same velocity time graph with the help of the simulation. Yes. So this is x-axis, this is y-axis, and time. Yes, time in x-axis, velocity in y-axis. I am choosing here. The time is 5-second difference. Okay, time is noted in second, velocity noted in meter per second. So the time letter is t and then velocity is 5. So now I am selecting that 5. That is the first one. First 5 seconds he crossed 10 meter. Next 10 minutes he crossed 20 meter, and next 15th minute he crossed 30, and then 20th second, sorry, 40 meter, and then 25th is 50 meter. Okay, you want to join the points. Next one, show the calculation. Yes, to identify that quantity, define the ratio of vertical change between points graph to the horizontal change between the same 2 point. Which is the right answer, ma? First, 1 or 2 or 3, it is slope or curvature or tangent. Which one is the right answer? It is the curvature. No, that's wrong because it is in slope. Okay, so the answer is in not correct means the red color will come. So the change of velocity over the change in time and referred as acceleration. Okay, that is called as acceleration. Doubt? Yes. Yes, ask me. What is the doubt, pa? Yeah, one student raised his hand. That is doubt. Yes, you type that doubt also. The product of velocity and time is, yes. What is velocity? Yes, good. What is velocity means? Velocity is the rate of change of displacement. Already I explained that last session, ma. What is velocity and then what is velocity? Same questions you write once again or different questions? Yes, velocity is nothing but rate of change of displacement. So we want to calculate that velocity means displacement by time taken. Understand? Velocity is nothing but rate of change of displacement. Is that clear? Yes. Okay. Thank you. Yes. The product of velocity and time is displacement. Very good. Super. Yes, that is the right answer. So, yeah, very good, pa. Next one is the area under the velocity time graph gives what is the answer? Rate of change of velocity or magnitude of displacement or speed of the object. Which answer is right? First or second? Thank you, pa. Magnitude of displacement or speed of an object? Yes, I am choosing magnitude of displacement. So magnitude of displacement is the right answer. Okay. Yes, next one is distance. Yes, the distance covered by the graph, the velocity time graph. This is the right answer. Each and every 5 minutes, 5 seconds, he crossed the same distance. Yes, this is the right answer, right graph for this. So, what is uniform motion? Yes, what is uniform motion? Uniform motion means I already told. Yes, the equal distance in equal travels of a person cover the same distance in same equal traveling time. That is called as uniform motion. Uniform motion means uniform motion is nothing but that person covers equal distance in equal travels of time. Okay, so that is called as uniform motion. Sriram? Time graph of uniform motion. And then next one is distance time graph of non-uniform motion. And then velocity time graph. These three details I explained in this session. From these three, is there any doubt? Means just you ask me, or otherwise I'll move to the next topic. That is, what is the centripetal acceleration and centripetal force, and then freely falling body. What is freely falling body? And then uniform circular motion. What is uniform circular motion? Uniform circular motion is nothing. Yes, there are different kinds of motions. Linear motion, circular motion, like that. This is uniform circular motion. Uniform circular motion means here, in this case, one stone is moved from that rope. Yes, it is one of the important game. I think all the students are known this game like that. Release the stone, moves along in a straight line, and that is tangential to the circular path. So this is because the stone is released, it continues moving along the direction of moving in that same instant. Yes. The stone is moved. Yes, I tag one stone in this area. I rotate the rope means the stone is moving in the circular path only. Okay, the stone is moved continuously. It rotates that same direction. So the direction of motion changes in every point when the stone is moving along in the circular path. When the object is moving in constant speed also in circular path, the velocity changes due to the change in direction only. This is called as the accelerated motion. Accelerated motion. Accelerated motion means one person is standing here. Yes, he rotate the stone. Yes, he tied one stone in the rope. This is the rope. Or thread. He tied one stone in this thread and he rotate the thread in circular path. The moving along the circular path of a radius. And then time is T, radius is mentioned as R, and time is mentioned in T part. So the speed of that stone is calculated by circumference of time taken. That is, circumference formula is 2 pi r by t. Okay, so in this experiment, we release a stone, moves along in the straight rail and then tangential to the circular path only. Because once the stone is released, continuously it's move along the same path only. There is no changes in this area. So the continuous move along the direction has been that same instant. It shows the direction of motion of the changes in every point. Stone is moving along in that area only. Object move with the constant speed in circular path. Velocity changes due to the, when we want to the change the direction means the velocity will be changes on that time only. Otherwise, the velocity is always same in that place. So it is called as accelerated motion. Revolution of Earth is the best example. Revolution of the Earth. Yes. The Earth is rotated around the sun. In solar system, yes, this is sun. All the planets are rotated around the sun. Each and every planets are rotate the sun. Okay, so this is the good example of accelerated motion. That is the revolution of the earth around the sun. Revolution of move around the earth. Yes, the third planet of the solar system is, yes, earth. The third planet is earth. The earth is rotate. Earth is always rotate around the sun. The moon is always rotate around the earth. So this is also a good example of accelerated motion, that is circular motion. Okay, and otherwise another one more example, clock. One more example also, clock. In wall clock, the hand, yes, there are two hands in this clock. One is hour hand, another one is minute hand. Yes, each and every hand is rotate around the clock. Yes, the minute hand is rotate around the hour hand. So this is also a good example of the accelerated motion. That is the revolution. How can we calculate the speed of this place means the formula of the speed and accelerated, that is speed. Circular motion, how can we calculate means circumference. So here circumference by time taken is the formula of, want to calculate the speed of uniform in circular motion. So speed means, we don't letter V, circumference. Yes, circumference means what? In circle, the formula of that circle is 2 pi r. Yes, 2 pi r by time taken. Circumference divided time taken. Circumference means the circle formula, square, circle, rectangle. In circle, we want to calculate the area of circle means, that is the formula of area is 2 pi r. Pi value is 22.7. Okay, so r is the radius. So 2 pi r by t is the right formula of calculate the speed in uniform circular motion. So uniform circular motion means we want to take one piece of thread and tie a small piece of stone in that end, rotate the stone in that circular constant speed. The thread is holding in his hand that person, he rotate the stone in that circular path. So the release the thread and the stone also rotate in that same direction, same path only. Okay. So is it clear, ma? Uniform circular motion also explain this manner. Is there any doubt means ask me each and every session. Yes, I am so happy because I received 4 or 5 questions from your side. One is velocity. I think other students also got in that place because that doubt is in your mind also. Once again, I explained in that time. Yes, he asks four questions. One is velocity, uniform motion, and then next one is acceleration. And you once again he asks the uniform motion. Okay, so what is uniform and non-uniform? Uniform means the same person cover distance in equal time travels, but non-uniform means the time duration and the distances vary. So that is the main difference between uniform and then non-uniform. Okay, is that clear, ma? Okay. Is there any doubt means you please ask me. Next session, I will tell that another one more topic. Okay, please go through and revise all the chapters from this area because this third term is very short duration. We want to maintain our studies more concentration because each and every minute is very precious. Within 2.5 months, we want to complete all the portions in that for our annual examination. So when we want to achieve our goal means we will take more effort to get that right and then good marks also. Okay, please revise all the portion. Any doubt means we will discuss in next session. Okay, thank you students. Jai Vidya Shakti, Jai Bharat, Jai Hind.